Imagine you are standing at the edge of the known world. Not the edge of a map where monsters lurk, but the edge of physics itself. Before you is a sphere of perfect, absolute blackness. It doesn't reflect light. It doesn't emit heat. It simply sits there, a hole in the fabric of reality. This is the event horizon. For centuries, we have been terrified and fascinated by this object, the black hole. We've been told that if you fall in, you are crushed to a point of infinite density, that space and time swap places, that the laws of physics just stop. But those are the headlines from the 20th century. We are living in the 21st century. We have photographed a black hole. We have heard it sing. And now, physicists are rewriting the story of what actually happens when you go beyond the point of no return. This is the true story of what's on the other side of a black hole. For a long time, the answer to what is on the other side was nothing. Or rather, the end. The story of the black hole begins with the death of a star. A sun many times larger than ours burns out, collapses under its own weight, and keeps collapsing. In Albert Einstein's general relativity, there is nothing to stop this collapse. You eventually reach a point called the singularity. For decades, this was the end of the road, a point where the curvature of space-time becomes infinite, where volume becomes zero and density becomes infinite. We were told that on the other side of a black hole is a mathematical error, hidden behind a curtain of gravity. But here is the secret that the textbooks are just starting to admit. The singularity is a liar. It exists on paper, but it almost certainly does not exist in reality. And why? Because of the single most disruptive force in the universe: quantum mechanics. To understand the other side, we have to stop thinking of gravity as the only game in town. When you try to crush matter into an infinite point, a point smaller than the smallest possible length in the universe, the Planck length, the rules break. This is the war between relativity and quantum mechanics. Recent research in non-perturbative quantum gravity suggests that singularities are an illusion. They are a sign that Einstein's equations are incomplete. According to studies from 2024, a true singularity cannot exist unless the black hole has infinite mass, which is impossible. So if there is no point of destruction, what is there? Let me introduce you to the first possibility, the Great Bounce. Remember how a star collapsed? What if it didn't crush to zero? What if it crushed to a maximum density, a quantum wall, and then bounced back?
In loop quantum gravity, this is called the Big Bounce. In this version of reality, the other side of the black hole is a white hole. A white hole is the time-reversed opposite of a black hole. A black hole swallows everything. A white hole spews everything out. Physicists have proposed models where a black hole transitions into a white hole via a thin shell wormhole. A traveler falling into a black hole wouldn't hit a wall. They would pass through a quantum tunnel and be ejected, maybe billions of years later, maybe in a different universe entirely. You don't die on the other side. You get thrown out. But let's hit pause on the physics of escaping. Let's talk about the physics of storage. There is a famous problem in science, the black hole information paradox. Stephen Hawking said that black holes evaporate. They leak radiation and eventually vanish. But if they vanish, what happens to the information of everything that fell in? The star, the spaceship, your memories? If they disappear, that breaks the laws of quantum mechanics. Information must be conserved. For a long time, everyone was confused. But now, a radical new picture is emerging. What if the other side of a black hole isn't a place, but a record?
Physicists like Gerard 't Hooft and Leonard Susskind proposed the holographic principle. Look at the event horizon, that glowing, boiling surface of no return. What if that surface is not just a boundary? What if that surface is the other side? The theory suggests that all the information that falls into the black hole is actually smeared and stored on the 2D surface of the horizon. Imagine you threw a book into a fire. In our world, it burns. But in the black hole world, the ashes would contain every letter, perfectly arranged, forever. An emerging framework, described as the Principia Cybernetica Cosmological Coda, takes this further. It suggests that black holes are not destroyers, but maximum coherence states. They are the deep memory of the cosmos. The interior isn't a spatial volume, it is a frequency domain, a place where time freezes into permanent, timeless memory blocks. The other side of a black hole might be the universe's hard drive.
But let's be realistic. Let's assume you aren't turned into data. Let's assume you are an astronaut with a very good, very long spaceship. What does the inside actually feel like? For a long time, we thought the inside of a black hole was simple, empty, just you and the singularity waiting at the center. We were wrong, astronomically wrong. In a rotating black hole, and almost all black holes rotate, things get complicated. There isn't just an event horizon, there is an inner horizon. Scientists Poisson and Israel discovered a phenomenon called mass inflation happening at this inner horizon. Here is the visual. As matter falls into the black hole, it gets stretched. Some fall straight in, some gets flung around. Inside, two streams of matter crash into each other, ingoing versus outgoing. When they collide, the energy doesn't just add up, it multiplies. The gravitational force at this inner horizon inflates to infinity. Not a point of zero size, but a wall of infinite energy density. If you are falling in, you will not have to worry about the singularity at the center. You will be vaporized by the Cauchy horizon first, a sea of relativistic plasma moving at the speed of light. The other side of a black hole is a wall of fire, created by the black hole eating its own past.
But there is a third possibility, the most romantic one. Einstein and Rosen wrote a paper about bridges in spacetime. We call them wormholes. In classical physics, wormholes collapse instantly. You can't go through them. But modern research into dynamic wormholes suggests that if you have a source of negative energy or exotic matter, you could keep the throat of the wormhole open. If a black hole connects to a white hole on the other side, that is a wormhole. But the real mind-bender is this. What if the other side of a black hole is our side? Just elsewhere? Some theoretical models suggest that a black hole could be a portal to a different region of our own universe, or a different universe entirely. But before you pack your bags, remember the catch. To an observer watching you from Earth, you never actually cross the horizon. You freeze, you redshift, you fade away. From your perspective, however, you cross the boundary. But the moment you cross, you are hit by that mass inflation firewall we talked about, or you are stretched into spaghetti by tidal forces. Realistically, the other side is a place where the geometry of reality turns you back into quantum foam. So, what is the true story? The true story is that for the first time in human history, we aren't just guessing about this anymore. In 2023 and 2024, scientists used gravitational holography and advanced mathematics to test the quantum cosmic censorship. This is the idea that nature hides singularities behind horizons. We have found strong evidence that in a quantum universe, naked singularities cannot exist. The other side is always hidden. But the biggest revelation comes from the replica wormhole.
You have heard of the firewall paradox, the idea that the event horizon itself is a burning wall. New analysis suggests that the space-time geometry of the black hole, as it evaporates, creates a Dirac delta force at the horizon. The other side, the inside, is defined by a topology that connects different times and spaces. We started this journey asking, what is on the other side? I cannot show you a photograph. I cannot bring you a rock sample. But the mathematics is pointing to a truth stranger than fiction. The other side of a black hole is not a place you go to die. It is a place where our understanding of reality goes to evolve. On the other side of a black hole, time becomes space. Space becomes a memory. Your atoms may be ripped apart, but the information that makes you, might become part of the fabric of the cosmos, imprinted on the boundary of infinity. The black hole is the horizon of our knowledge, and on the other side is the future of physics.
Maybe one day we will find the quantum gravity equation that solves this mystery. Until then, keep looking up.